Hello, this is Mr. Agbamu Idonogrene. In this video, I want to demonstrate how to solve this kind of question that involve the folding of a sector into a cone, or how do you cut a cone into a sector. This is a common question in WAEC exam, just like the one I have here. In 2006 WAEC examination, question 6, this is a theory question. And some students find it difficult to understand the principle. So I said, let me do the demonstration of this kind of question. And I will use this app, my GeoGebra Classic app, which I usually use in my mathematics class. So this is an applet from the GeoGebra Classic website. You can see there, GeoGebra Classic. Now I want you to understand this principle so that you know that the formula is not actually a difficult one. So it's the normal formula that you know for sector, normal formula you know for length of an arc, and the normal formula you know for cone. The only thing is you need to understand which part of the sector is equals to which part of the cone. So this is a cone, this is a sector. So let me close this sector now, or let me fold this sector so that you see what will happen. So when I click on this slide, you can see what is happening. I'm folding the sector. You can see these two places, they will lap on each other now. So as they lap on each other, you can see this is now a cone. And the part that lap on each other now, they are the slant height of the cone. So you can see, let me open it so that you see it well. So this is the slant height of the cone, which is this part. So when you hold the two side of the cone and of the sector and cover it, it will form a cone. Now remember, this part, which is the slant height of the cone, is also called the radius of the sector. This is the first principle you must not forget. The slant height of the cone, let me get my pen. So this slant height of the cone, which is called h on this place, like this h, is the same thing as the radius of the sector. So don't forget that. So let me just use small r for example, or let me use capital R. Let me delete this so that we'll not have some confusion with the other radius, which is the base of the cone. So if I use this h, which is the slant height of the cone, is the same thing as let me use capital R, is the same thing as radius of sector. So slant height of cone equals to radius of sector. So this is the first principle you must understand when a sector is being folded into a cone. You can see it, how the slant height has become the radius of the sector. You can see. So this one thing you must not forget about this kind of question. Now let me seal it and cover it. Now watch. I've covered the circle now, which is this bottom now of the cone. Now this bottom of the cone, if you observe very well, that is this circle now. If you observe very well, let me open it again. You will see that this circle of this cone is going to be equals to the arc. You can see it's equals to the arc of this sector. You can see the arc of this sector, which is this long arc here. You can see is equals to the length of this circle. So another important thing you must not forget here is, if I take L to be length of arc, so if I use L as length of arc, so this length of this arc is equals to the circumference of this circle, which is length of the circle, and let me call it C. So this is the basic principle about folding a sector into a cone. If you understand this, you can solve whatever kind of question that involve cutting a cone into a sector or folding a sector into a cone. So let's go to the calculation now. With this understanding of this applet, I believe when I bring out the formula of this question, you will understand why we are using that formula. There's nothing so special about it, nothing to memorize, nothing to cram. Just understand the principle. See the way I'm folding it and covering it So you will get it clearly with that. All right, let's go to the calculation now. Now let's delete all these ones. I don't need them. Okay. Now I've brought out two principles from this kind of question. Let me impute my formula. Okay, now what I brought out from this folding of sector into a cone, I brought out two basic principles. I said the length, the length of arc, very important. The length of arc of sector now, very important. We said is equals to the circumference. The circumference of the circle. Very important. This is very important. So let me state this formula so that you get it out. So let me use f of x in doing that. So let's impute the formula. So what is length of a sector? So length of sector, you already know the formula now. That is theta divided by 360, which is times 2 pi r. So this is the formula for length of an arc. So take note of this. So we say this length of an arc is equal to circumference of a circle. Now remember, this is for sector and I use capital R in the other case. So I want to differentiate the length of the radius of sector from that of a cone. Okay, or let me use capital L. I don't want to cause confusion with R. So this is equals to 2 pi r. So let's go back to our Microsoft. Now, let me make it clear so that it will not cause more confusion. Let's put solution first. Solution. Let me bold the solution. Okay. Then let's get it clear. So let L equals to radius so that you know the radius we are talking about, radius of sector. Then let's use small r. Small r equals to, I need small r, not capital R. So let's take small letter r equals to radius so that you get the difference. Radius of base circle. So with this, you will get the meaning of the terms in the formula here. So if L is the radius of sector, you can see it, then small r is the radius of the base circle. So you can get it clearly. Let's see the applet. So this is the base circle, you can see. So I'm using small r as the radius of this base circle. Then you can see the slant height, which forms the radius of the sector. So the slant height which forms the radius of the sector, you can see it. So I'm using L to represent the radius of the sector, so that we will not have some confusion when we are solving or substituting. So this is the first thing you should get. Then the first principle from this analysis here, the first principle is the length of this arc. You can see it, the length of this arc is equals to this circle circumference. So that is the first thing I demonstrated, and this is the formula. And you can see, so since 2 pi is common to both sides, so let me get my pen. Since 2 pi is common to both sides, I can cancel out 2 pi. We cancel out 2 pi. So leaving r alone. So the first formula has been generated so that we can calculate this question in this, for us to be able to do the calculation. So let me remove this. So you can see the question says find the base radius. So you can see that base radius is small letter r. So radius of base circle, which is the base radius, small letter r. So when 2 pi cancel 2 pi, let me edit it so that we can do that. So if the 2 pi here cancel this 2 pi, in my next line, I'm going to have small r, which is going to be theta divided by 360 times So let's use capital L as I said. So this is the first formula we are going to use. So the first part of the question is already being calculated, which is base radius. And this formula is very, very important. Don't forget it whenever a sector is folded to form a cone, or whenever a cone is cut to form a sector. This is a very important formula. The length of arc of this sector will be equal to the circumference of the sector. So that is the basic thing you need to get. So with this, I think we are good to go. So the first solution now, which is the Roman figure 1. So the Roman figure 1, this we have seen our formula already. So R is equals to get the angle of the sector you can see is subtend 90 degrees at the center, which is the theta is the 90 degrees. Then the radius is 8. That is the sector now. The sector of a circle of radius. So radius of sector is 8. So L is 8. Angle is 90. So what are you looking for? Radius is settled. So we can do that calculation here. So if I want to calculate this, I'll go straight to the point now. Let me use this to impute. So we said theta is already 90 degrees. Theta is 90 degrees. That one is settled. Then the radius, which is the capital L for the sector, is 8 centimeters. So that one is settled. So when you get that, the next thing is to do your calculation of radius. So say radius is theta, which is 90 divided by 360 degrees, then times your radius, which is 8. So if you do your calculation, do your division, I think everything will be settled. And that is that. So let me just do the calculation very fast in this FFX. So if I use this, let me put it in this place, in this curly bracket, which is 90 divided by 360. So times 8. So our answer is 2. So the radius is 2 centimeters. So that is the calculation, that is the answer for the first part of this question. So the base radius now, which is the radius of the circle. Let me go to the GeoGebra. So this circle now, which is the circle of this cone, the radius is 2 centimeters. While the slant height, which represents the radius of the sector, is 8 centimeters according to the question. So that is 8 centimeters. So that is the first part of the question. So every other part is normal formula that we are used to. So it asks for the height. So we are looking for the height of the cone. So we already know that in a cone, you know this relationship. Let me come back here. So you can see that the height of the cone and the radius of the base, they are connected by 90 degrees. You can see the 90 degree symbol here. So radius of base, height of cone, they are connected by 90 degrees. So this is the slant height, you can see. This is the slant height, which is the same thing as the radius of sector. You see, slant height, which is the same thing as radius of sector, and they form a right angle triangle. So all I need to do here, I will use our Pythagoras theorem, and the height will be calculated. So the second part of the question, which is Roman figure 2, that the height is settled. So if I go to Roman figure 2, so using Pythagoras now, using Pythagoras rule. And what is Pythagoras rule? Let me state it. You say the hypotenuse square, but I'll just use our analysis here. So our own case now, the hypotenuse is the slant height. So the slant height square is equals to the sum of the square of the other two sides. So the other two sides, we have our small r square plus the height itself, which is the height square. So this is it. Then if I do my substitution, so the slant height, we already got 8. So that is 8 square. 8 square equals to the radius, we have calculated it to be 2. So 2 square, then plus our height is what they say we should calculate. So we are looking for h. So now we are collecting like terms. So without wasting time, I have my h square will be equals to the square of 8 is 64 minus 4. So I have my 64 minus 4. So after squaring 8 and squaring 4, collecting like terms, so I will have 64 minus 4, and which will finally give me 60. So h square equals to 60. So to get my final result, so h will be equals to the square root of 60. And what is the square root of 60? H is equals to, let me use my curly bracket. So h is equals to square root 60. And that is this in centimeter. So that is 7.745. So you can approximate to whatever decimal you want to do your approximation. So it depends on the question. So this is the answer to Roman figure 2, which is the height of the cone. Then finally is the volume of the cone. So which is normal formula for volume of a cone. And what is the volume of a cone? That is 1 over 3 pi r square h. 1 over 3 pi r square h. So that is that. There's nothing so special about that. Okay, let's end this calculation now. So Roman figure 3 asks for volume. So volume of a cone is what? The volume of a cone is equals to, so if you use the formula for volume of a cone, it's 1 over 3 pi r square h. So this is the volume of a cone, 1 over 3 pi r square h. So if I use this formula, I'll end our business in this calculation. So let me just edit it and finish the work. Okay, let's finish it now. If I move to the next line, which is 1 over 3 times pi times, so we said r is 2, we have calculated that already, which is 2 square. Forget that. We say pi r square, so 2 square, then multiply by h. So h, I can use 7.75. Let me use 7.75, that is 2 decimal place. Let me just use that. All right, so with this, we can end our work now. Let me use my calculator in FX. So if I type 1 over 3, 1 over 3 times pi times 2 square, which is 4, then times 7.75. So this will give us our answer. And remember, this is a volume, so it's going to be centimeter cube. So if you approximate to whatever decimal place, 2 or 3, whatever decimal place, so this is your answer, 32.463, and so on. So that is all about this calculation in this question. So the volume of the cone in this question is 1 over 3 pi r square h. So that is that. Finally, this question has been solved. The main principle is length of an arc of this sector into the circumference of the sector is to remember the principle from this applet that this slant height, which is the radius of sector, is going to be equal to the slant height of the cone, and this arc, which is the arc length of this arc of this sector, is going to be equal to the circumference of this base circle of the cone. So by the time you understand this, you are through with this kind of questions that involve folding of a sector into a cone. So this applet, you can get it in one of my videos in my channel. If you go through my channel, you will see one of the videos I did how to get this particular applet in case you want to use it in your class room. I can also put the link. I'll put the link of this applet in the description of this video so that you can download this applet and play around with it in your classroom as you teach your children in class. So that is all I have for us in this question. The base radius following these steps, the base radius is 2. Then the height of this cone, following the calculation, the height is 7.745, which is approximately 7.75 if you approximate it to 2 decimal. Then finally, the volume of the cone is using this formula 1 over 3 pi r square h, which is 32.46. That is all I have in this calculation. Do have a nice day.